Hello and welcome back to our journey through the solar system. Today we're going a little bit farther out, but still within the Kuiper Belt to talk about our third dwarf planet, Haumea. Haumea is named after the Hawaiian goddess of fertility and childbirth. So per the IAU naming conventions, the bodies that are located beyond Neptune should be given names from mythology that are associated with creation. Now, Haumea is a relatively new addition to our knowledge of the solar system, having only been discovered back in 2003 or 2004, depending. Story time. This is actually a kind of interesting controversy about the discovery of Haumea. So two different teams basically lay claim to discovering this object, an American team led by astronomer Mike Brown, and a Spanish team led by astronomer Jose Luis Ortiz Moreno. So the American team discovered Haumea just after Christmas of 2004. However, they kind of held off on announcing it or submitting its discovery to the Minor Planet Center because they wanted to gain a little bit more information about it and its nature before they did so, and they were also kind of slowed down because of the birth of Brown's daughter. So it wasn't until July of 2005 that the American team basically published an abstract saying that they were going to announce this new Kuiper Belt object at a conference in September. Now, it was in that same month, July of 2005, that the Spanish team discovered Haumea in their 2003 data taken from their observatory. The Spanish team quickly took some confirmation images in July 2005 to confirm their 2003 data and basically prioritized submitting this to the Minor Planet Center as quickly as possible to announce the discovery of this object. Now, the IAU usually considers the discovery credit to go to whoever basically submits the information to the Minor Planet Center first. In this case, that would be the Spanish team. And indeed, at the time, the American team was, a little disappointed to be scooped, but they congratulated the Spanish team and they basically conceded the discovery to them. Until the American team learned that the Spanish team had actually accessed the logs regarding their observations of Haumea just prior to making their confirmation images of Haumea in July of 2005. Now, the Spanish team never mentioned the American observations or the fact that they looked at them in their submission to the Minor Planet Center. And in fact, the information that was available in those logs would have been enough to kind of point the Spanish team on where to go back to look in their 2003 data and do what's called pre-cover. So basically look at pre-existing data and recover an object that has been discovered later. And so they could have done that from the data in the American logs, although of course they say that they did not. The Spanish team says they only accessed the logs because they were trying to make sure basically that this object they had detected was a new object and wasn't already known. So kind of once the American team realized that their data had been accessed, they actually mentioned it to the Spanish team, and the Spanish team never said, yeah, that was us. And so the American team found out later, basically by tracing IP addresses, I think, that it was actually accessed by the Spanish team because they could trace it back to their observatory. And so then the American team was like, whoa, wait a minute, this is sketchy. We think that you looked at our data, went back and found it in your 2003 data, and then said, oh, hey, look, we discovered it, and kind of tried to jump on it really quickly after we had already published this abstract saying that we were going to announce it. Whereas, of course, the Spanish team says, no, we discovered this in July 2005. We just tried to look and make sure it wasn't already announced, and, we did what we were supposed to do, and we submitted it to the Minor Planet Center. Supposedly, on a telephone call between Ortiz and Brown, Ortiz told Brown that he had a penchant for hiding objects and that this was alienating other astronomers and it was bad for science. And so, there's definitely a little bit, I think, of personal animosity here, maybe. In any case, the American team filed a formal complaint with the IAU, basically alleging scientific fraud and saying that the Spanish team were not actually the true discoverers and that the credit should go to the American team. Whew, drama. So, normally, the team with the discovery credit kind of gets priority in naming these objects. They don't get the final say, that belongs to the IAU and their naming committees, but they get priority. So the Spanish team submitted their name for the object, which was a Tacina, which was named after an Iberian goddess of the underworld, although for various arcane reasons may not have actually been suitable per the IAU naming conventions for this particular body. And the American team submitted the name Haumea. Now, this was named after a Hawaiian goddess who was associated with creation, with this fertility and childbirth, which suited the IAU naming conventions. And the team chose it in honor, basically, of the observatory where they discovered this object, or claimed they discovered this object, which was located on the Hawaii island at the Mauna Kea Observatory. So it was kind of an homage to the Hawaiians and, in gratitude for them letting us use their land to discover these objects. So because of this controversy over who should have the discovery credit, this kind of naming process with the IAU was very delayed. Eventually, in 2008, the IAU held their official vote to name Haumea, and obviously Haumea won. And there's actually 2 committees on the IAU that had to vote on this. The Committee on Small Body Nomenclature and the Working Group for Planetary System Nomenclature. Yeah, there's a surprising amount of bureaucracy involved in science. Anyway, so the name Haumea won, but it was a pretty close vote. In fact, I think the CBSN, it only won by one single vote. And when they announced this, they gave the name Haumea. However, the date of discovery that they put on it was the discovery date the Spanish team claimed, and the discoverer's name or like discovery credit, they just left blank. And that was really ultimately the resolution of this, basically, is that no one really got the credit. Obviously, the Spanish team thinks it belonged to them. The American team thinks it belonged to them. The Spanish team is annoyed that the American team got their name approved. The American team is annoyed that they're not listed as the discoverers. It's all just kind of a mess, but well, science drama for you. But in any case, this is now how we have the dwarf planet Haumea that does not have an official discoverer. So aside from all this drama, what do we actually know about this dwarf planet? Well, so just like Pluto, it is located in the Kuiper Belt. It has a much more eccentric and inclined orbit than is typical of, for example, the classical planets. Haumea is a little bit farther out than Pluto with a semi-major axis of 43 AU or so, which actually puts it in a kind of weak intermittent 7 to 12 resonance with Neptune, which means every 7 orbits of Haumea is 12 orbits of Neptune. This is a 5th order resonance, so it's not particularly a strong one. Haumea's orbit is a little bit less eccentric than Pluto's. It's about 0.2 eccentricity, but it's more inclined. So it has an inclination relative to the ecliptic of 28 degrees, which is really quite significant. So mass-wise, Haumea is kind of in the middle here. So it's about 4.5 times more massive than Ceres, but it's about 3 times less massive than Pluto. So it's kind of in the middle, at least of the dwarf planets that we've talked about so far. Now we're actually able to measure the mass of Haumea because it has moons. And we can use the motions of these 2 moons, which are called Hayaka and Namaka, again taken from Hawaiian mythology, to measure the mass of Haumea. Now for most Kuiper Belt objects, we can't do that. So in general, the Kuiper Belt objects are more characterized by, say, their brightness than by their physical size or mass. So in terms of brightness, Haumea is the 3rd brightest KBO that we know, after Pluto and Makemake. Now, like Pluto, Haumea is so far away and so small that we can only see it as kind of a point source. So everything that we are learning about Haumea, we have to learn just from one thing, and that is its brightness over time. This means we don't know very much about the surface or the atmosphere of Haumea, but we can actually learn a surprising amount of information just from its light curve. And one of the most interesting things about Haumea is its rotation, which we can measure from its light curve and how it periodically changes in brightness. And this means that Haumea has a rotation period, that means how fast it spins, of about 4 hours, making it one of the fastest spinning objects in the entire solar system. And this incredible speed of rotation is actually deforming Haumea. So just like the Earth's rotation makes it an oblate spheroid, so the equator is a bit wider than the poles because of the spin, that similar sort of thing is happening with Haumea, but it's spinning so fast that it's so deformed, it's not even an oblate spheroid anymore, it's actually what's called a triaxial ellipsoid. So it's this really odd shape. And we can measure this shape from the light curve as well. So that's another piece of information that we can get, and it makes sense with this fast rotation period that it has this distorted shape, so we can make sense of it that way. Now, the probable reason that Haumea is spinning so fast and on this inclined orbit is that it was part of a large collision at some point. This is also supported by the fact that we know that Haumea is part of what's called a collisional family. So a collisional family is basically a group of objects that seem to have a similar composition and similar orbital elements, so that you could kind of trace them back to a single object that was, collisionally destroyed and led to all these fragments. And so Haumea is the largest member of this collisional group, and so it does seem that this is kind of the source of its excitation. This collision likely also produced the debris that became the 2 satellites of Haumea and its ring, because yes, Haumea has its own ring. It is the only Kuiper Belt object, it's the only trans-Neptunian object we know of that has a ring, and I think that's pretty cool. So you might be wondering, how do we know that it has a ring if we can only see it as a point source? So another way that we can kind of glean information about Haumea is by looking at the stars it blocks out as it travels by them. And this is called stellar occultation. And based on stellar occultation, this ring was discovered back in 2017. And we can also use this sort of stellar occultation to learn about the size and shape of Haumea, which seems to be perhaps a little bit in tension with what we were learning from the light curve, which could indicate perhaps maybe some different materials. Now, because it's located so far out in the solar system, and because it's so bright despite being so small, Haumea must be a very icy body. Its albedo, which is a measure of basically how much light it reflects, is somewhere between 0.6 and 0.8, which is over double that of Earth's, which is on average about 0.3. So this is about the albedo. It's about as bright as freshly fallen snow. So it's a very bright, icy planet, dwarf planet. Now, beneath all of that ice, there's probably some sort of rocky core. So for now, we can only picture Haumea in models like this one, based on the information that we can kind of get from the small bit of light that we get from Haumea. But maybe someday we could get a chance to see this dwarf planet up close. I'm sure it would reveal just as many exciting new things as Pluto did. However, there are no missions that I know of that are planned or even, being proposed to go to Haumea. It would probably be a good 15 to 16 year trip, at least, depending on, the orbital dynamics involved. It certainly would not be a short mission, but maybe someday we can get out there and see this little dwarf planet up close. Now, Haumea may not be as well known as some of the other dwarf planets and objects in our solar system, but it is a very interesting object in its own right, with its breakneck rotation speed, its weird ellipsoidal shape, and its ring and moon system, which is amazing. It's just very cool, and it's amazing how much we've been able to learn about Haumea, and I hope that we continue to learn much more about it to come. So thank you so much for joining me for our trip to Haumea today. I hope you will join us again next time when we go to the dwarf planet Makemake. Thank you so much for watching, and I hope you have a good one. Bye.